Okay, grade 7. This is lesson 6, chapter 9. It says here, change in dimensions. And we need to know what are similar solids, okay? All right. So, please write this. Similar solids because they have the same shape and size, or the corresponding linear measures are proportional. Okay? Please write that. Similar solids. Okay? For solids to be similar, they must be the same shape and this, but they don't have to be the same size. You cannot compare a cylinder to a cube. You cannot compare a cylinder to a cube and say they're similar. Why? Because they are not the same shape. Okay? So for you to be a similar solid, one, you must be the same shape. Okay? Now, in this lesson for changes in dimensions, we need to remember our formulas for volume and our formulas for surface area for our three-dimensional shape. So, when we are dealing with changes in dimension in lesson 6, we will be referring to the different formulas for volume and surface area if the question did not give us the volume and the surface area. If the question gave us, then the formula for finding the volume is not important. If the question did not give us, it just gave us a picture like this, then you must do. You see? It just gave you a picture. Then you must find the surface area. Okay? All right. So, that's why I wrote here, you must remember the formulas for each solid. You must. So let us review the surface area formulas for cone. We just finished this lesson. Surface area for cone is base area plus lateral area. The base of a cone is a circle. So you will do pi times radius squared. Then you will add the lateral area, pi times radius times slant height. And then you will add your answers from your two brackets. And that will give you the surface area of a cone. When I write SA, I mean surface area. So when you see this, you know I am talking about surface area. When I write BA, you know I'm talking about base area. When I write LA, you know we are talking about lateral area. These are things you should know. See, even your book writes it. All right. When we have a cube is made of 6 equal squares. When I want to find the surface area of a cube, I have to multiply the area of each square. So I have to multiply side times side. That will give me the area of one square. And because there are 6 of them, I will multiply by 6. So for me to find the surface area of a cube, I need to find the area of 6 squares. And how do I do that? 6 times the area of one square. How do we find area of one square? Side times side. So 6 times side is 6 side squared. Okay? All right. Then we have a cylinder. How do we find surface area of a cylinder? Remember, you need to know the radius and you need to know the height. Okay? Now, surface area of cylinder is base area plus lateral area. How do you find the base area? You have 2 bases in a cylinder. The top circle and the bottom circle. Okay? And then you have the lateral area, the area that goes around here. Okay? All right. So, how do you find area of 2 circles? 2 times pi times radius squared plus 2 times pi times radius times height will give you the lateral area. Then you put your dimensions in and you find your answer for each bracket and then you add them. That gives you the surface area of a cylinder. How do you find surface area of a rectangular prism? you should know that another name for rectangular prism is what? Cuboid. Questions will be asked different ways. So when you see cuboid, you should know it is rectangular prism. Okay? The dimensions of a rectangular prism are the length, the width, and the height. If you know these three dimensions, you can find the surface area. So, a rectangular prism has 2 length and 2 width. That means the front and the back. Sorry, the length and the width will be the bottom and the top. So the length and the width, there's 2 of them. One on the floor, the other one on the ceiling. Okay? Then you have this, the width and height. That is the same, so you have 2 of them. And then you have the length and the height. You have the one in front and the one at the back. So how do you find the surface area of rectangular prism? 2 times length times width. And then you add. This has to be add. 2 times width times height. And then you add 2 times length times height. Why am I multiplying by 2? Because there's 2 of each. There's one in front, one at the back. One on the floor, one on top. One on the right, the other one on the left. So that's why each bracket has 2. Okay? So that tells us how to find the surface area. You multiply to find your areas, and then you add your areas up together. Now, how do you know you have similar solids? How will you know? One, you must have 2 of them. You can't compare 1 to 1. There has to be 2 of them. Okay? 2 or more. But in this lesson, you'll only be seeing 2. Well, maybe sometimes you'll see 3. But you must have at least 2. Okay? One must be big and the other one must be small. They cannot be the same size. One must be a big one, another one must be a small one. Okay? They must be the same solid. They have to be the same solid. So you see here, I have 2 cylinders. I have 2 cones. I have 2 rectangular prisms. One is small, the other one is big. One is big, the other one is small. It doesn't matter. It depends with the question. They might start with the small, they might start with the big. It really does not matter. Okay? But as long as there are 2 of them. Now, the first shape is always called the pre-image. The first one, the one on the left, is always your pre-image. Whether it is big or small, the shape on the left is your pre-image. The shape, if it is up and down, the shape on top is the pre-image, because it was the first one that was drawn. That's the first shape, and then this is the second shape. This is the first shape, and then this is the second shape, like that. Size does not matter. Just because it is big does not make it the first shape. Okay? The small one, as long as it is the first one, it is the pre-image. As long as it's the big one, it is the... as long as it's the first one, whether it is big or small, it is the pre-image. The one on top, if they are arranged like this, because sometimes they can come left to right, sometimes they come up and down. Okay? Then, there are very important formulas you must not forget. You will need them. In this lesson, you must know how to find the scale factor. You must know. Okay? So, if the question tells you, find the surface area of the image, how will you do? So that means they are asking you for the surface area of this. This is your image. You will take the surface area of the pre-image. You will multiply by the scale factor, but you must square the scale factor first. Then you multiply. You must put it like this in your calculator. If you forget to put this, your answer is wrong. Because it is area, this must be squared. Scale factor must be squared. If the question wants the surface area of the pre-image, you will follow this formula. You will say surface area of image, you will divide by the scale factor squared. You must do this. This squared must be there. Okay? If you want to find the scale factor, you must press this. First, you press the square root sign. This is called the square root. And then you press your fraction bar, just like that. So, you press square root, where is it? Square root. And then you press fraction bar. And then you put your values, and then you press your answer. So, when you have scale factor and you're dealing with surface area, you use the square root. This sign is called square root. Square root. All right, the volume, it is the same. It's the same formula. All is changing is your power. Your power here was 2. Your power for volume is 3. It is the same formulas. And this one is cube root. Okay? So here you will multiply. To find the volume of the image, you will multiply volume of pre-image times the scale factor to the 3rd power. Please use your brackets. Use your brackets. Use them. So this way you won't forget. Excuse me. To find the volume of the pre-image, you will divide the volume of the image by the scale factor. To find the scale factor, you will define the cube root. If it has 3 over here, it is called cube root. Okay? So you find the cube root of the volume of the image and the volume of the pre-image. How do I find cube root on the calculator? I press shift, I press the square root sign, and there is the cube root sign. And because I want a fraction, I will press the fraction bar. Just like that. Okay? Again, I will press shift, I will press the square root sign, and then because I need a fraction in there, I will make it like that. Okay? All right, now let us do some examples. I wrote formulas. I wrote formula for volume of cone. There, formula for volume of cone. Formula for volume of cube. Formula for volume of cylinder. You should remember these because we've already done them in lesson 1, 2, 3, 4, 5. All these formulas we have done. So you should know all of them. Each one of them. Don't forget them. All right, let's do some examples. So I will do example A, B, C, and D with you. And then you will do guided practice. Okay? Now, you must know how to read. If you read incorrectly, you will do it wrongly. So I'm reading the surface area. So this is important. With my pencil, as I read, I underline. The surface area of a triangular prism is 34 square centimeter. Very important. What is the surface area of a similar prism with dimensions that are 3 times? So this 3 times is what I'm calling the scale factor. If you see a number with the word times, that is the scale factor. As great, that means my answer must be more than 34. If it says at least, my answer will be smaller than 34. The question says as great. So as the original prism. Original prism is the pre-image. So that means the question wants me to find surface area of image. So I write my formula. Example A. So I write surface area of image equals surface area of pre-image times scale factor squared. Scale factor squared. What is the surface area? It is 34 square centimeters. So 34 centimeters squared. What is my scale factor? It is 3. So I will put 3 into bracket squared. So this becomes 34 centimeters squared times 9. I take my calculator and I press 34 times 9 and I got 306 centimeters squared. And this is my answer. Now let us read B. We read B together. A giant box. That means a big box. Giant means box, big. A big box has a surface area of 352. So that means that's my pre-image because that's the first box I read. So this is my pre-image. Pre-image, okay? If the dimensions of a similar box are smaller, that means my scale factor will be less than 1. I see this word, I know my scale factor has to be less than 1. Okay? If I see great, my scale factor has to be more than 1. And because I saw smaller, my scale factor must be less than 1. And I am correct because my scale factor is here. This number is less than 1. I want to find the surface area of the smaller box than the giant box by a scale factor of 148. Then I will write B, surface area of image equals surface area of pre-image times the scale factor squared. Then what is my area? 352 square meters times 1 out of 48 squared. The reason why I make you use the bracket is when you have a fraction, you must use a bracket. So use a bracket, whether it is a whole number or a fraction or a decimal. Use the bracket. If you don't, your answer will not be correct. Okay? Now, let us do the work on the calculator. So you have 352 times bracket fraction 1 out of 48. Close the bracket. Wait. Come here and then close the bracket and then press squared. Just like that. And then press equal. And then press SD. So, are we rounding? It didn't say. So you can either leave your answer as a fraction or you can leave your answer as a decimal. I'll suggest you write both. So let me press SD first. So this is 11 over 72 meters squared. And then the decimal will be 0.15 meters squared. And then you box your answer. Okay? And that is how you do A and B. Now let us do C. Okay? Now C is volume. Keyword there is volume. And the volume of a square pyramid is 512 cubic centimeter. What is the volume of a square pyramid with the dimensions 1/4? 1/4 is written as 1 out of 4. So this is the scale factor. You need to know how to read numbers in words and as a number. So 1/4 is written 1 out of 4. So we will do volume of image equals volume of pre-image times scale factor to the third power. So what do we write? 512 cubic centimeter, so centimeter to the power of 3 times 1/4 bracket to the third power. And you come here to your calculator, 512 times bracket fraction 1 out of 4, close the bracket, to the power of 3. You press this one that does not have a number here, and then you press 3, just like that. Okay? And then you get 8. So there is your answer, 8 cubic centimeter, and you box it. Or if you don't want to do that, you can delete. You can delete that. And then you can multiply by 1/4. So wait. Delete this. Then you put times 1/4 times 1/4. Like that, 3 of them. And then you come there, and then you close your bracket. And see, our answer is the same. See? Our answer is still the same. So you can either do this, or you can use this one. And you put 3 when you press there. All right, let us do D. Okay, we read and then we do D. It is important for you to know how to read. If you read incorrectly, your answer will not be correct. A cylinder has a volume of 432 cubic meters. What is the volume of a cylinder with the dimensions of 1/3? 1/3. So this is my scale factor, 1/3. That's how you write that, of the original, okay? So you do the same thing. So you write volume of image equals volume of pre-image times scale factor to the 3rd power. Then you put your values. You have 432 cubic meters, yes? So cubic meters times 1/3 to the 3rd power. Okay? Let's do more steps here. 432 cubic meters times 1/3 times 1/3 times 1/3. Remember when we learned in term 1 how to multiply fractions? What did we say? This is 432 meters cubed times 1 times 1 times 1, and 3 times 3 times 3. And this becomes 432 meters cubed times 1/27. How do I know it is 27? 3 times 3 is 9. 9 times 3 is 27. Or you do it over there. But you should know this. See? 27. Then this becomes 432 meters cubed over 27. How do I know? Because I multiplied by numerators. So what I need to do is 432 divided by 27. And what do I get? 16. And my answer is 16 cubic meters. And I box my answer. Or I can just put it like this in the calculator. Let's do and see if we're going to get the same. 432 times fraction 1/27. Okay? And there, it's the same thing. You got 16. Whether you do it this way or you do it this way, it doesn't matter. The answer should still be the same. This is what is important. If you do this wrongly, everything else will be wrong. If you read incorrectly, everything else will be wrong. You should know how to write that. Read those. 1/4, 1/5, 1/6, half. You should know how the spelling is. So, half is 1 over 2. 1/3 we did here, 1/3. 1/4. Okay? 1/5. 1/5 is 1 over 5. 1/6 is 1 over 6. Like that. 1/9. 1/9. 1/9 is 1 over 9. Like that. 1/10, 1 over 10. 1/11, 1 over 11. Like that. Please read correctly. The minute you read wrongly, your answer will not be correct. All right. So do guided practice. Because I already did A, B, C, and D. Do guided practice 1, 2, 3, and 4. Answer these 4 questions. And then we'll see each other tomorrow. And you do Aleph. And you do all the other things we do. Aleph, all that. Okay? Bye.